Hello students, we are solving the IB Math AA HL past paper questions and currently we are solving the IB Math AA HL May 2023 paper 3 times on 1 past paper. Today we will be solving the question number 2 of this paper. You will be getting the link to the first question of this paper and the links to the other solved questions of the other papers in form of playlist in my channel NS Online Math Tutoring classes. So without any further delay, let us start answering question number 2. The maximum mark is 30. It is saying in this question, you will investigate the maximum product of positive real numbers with a given sum. Consider the two numbers x1 and x2 which belong to the set of positive real numbers. They are not saying that x1 and x2 are integers, positive integers. They are saying x1 and x2 are two positive real numbers such that x1 plus x2 is equal to 12. So part A's question is find the product of x1 and x2 as a function of f of x1 only. Okay. So we are given that x1 plus x2 is equal to 12. And we have to keep only x1. Therefore, x2 is equal to 12 minus x1. Okay. Now we have to find the product of x1 and x2. So, and that will be the function expression. So it is f of x1. F is a function of x1 only. So this will be the product of x1 and x2. So in place of x2, we'll be writing this expression, 12 minus x1. So it will be f of x1 is equal to x1 times 12 minus x1. Okay. So this is the answer for the subpart E. Okay. Subpart B. It is containing two further subparts. The subpart I is saying find the value of x1 for which the function is maximum. It is containing just a single mark. If you can get the maximum value, the value of x1 for which the function is having the maximum value, fair enough, from this expression, of course. Or else, let me rewrite this a bit. So this one can be written as, I'm taking this negative sign outside, so it is negative x1 and x1 minus 12. So definitely it is a quadratic expression and the roots of this quadratic expression will be, the zeros rather, will be x1 equal to 0 and x1 equal to 12. And since you are having a leading minus sign in front of the expression, you will be having an inverted parabola. The graph will be, I'm just drawing a rough sketch, okay? This is the y-axis, this is the x-axis. This is the x equal to 0 point and this may be the x equal to 12 point. And it will be, the parabola will be inverted like this, okay? I'm definitely not drawing an exact thing. It is a rough sketch showing that the parabola will be an inverted parabola and you will be having the maximum point. So that is stated by the function is having the maximum. Okay. Only when the parabola is inverted can you have a maximum point. Else you have the minimum point. So for which x1 value will the function value be maximum? See, this is the 0. One of the zeros is 0. Another one is 12. So the line of symmetry will be passing through x value as 6. So therefore, x1 is equal to 6. It is just containing a single mark. And I have drawn the, I have rearranged this function expression and I have written f of x1 equal to negative x1 times x1 minus 12. So this is telling us that the two zeros will be, one will be 0 and the other will be 12. I have drawn those two zeros. I have shown the parabola. I have shown the line of symmetry. So definitely I get 1 mark. So x1 equal to 6, okay? And this one was bi. And bii, Hence, show that the maximum product of x1 and x2 is 36. So, the maximum product will be, function will be maximum when x1 is equal to 6. So, maximum product, it is also containing a single mark. Maximum product is when x1 equal to 6. So it will be 6 times what is x2? x2 is 12 minus x1. So it is 12 minus 6. 12 minus 6 is 6. So 6 times 6 is equal to 36. Okay. So this is the answer shown. Consider Mn of S to be the maximum product of n positive real numbers with the sum of S, where n belongs to the set of positive integers. Because it is the number of real numbers, it has to be an integer, a positive integer, and S belongs to the set of positive real numbers. Okay, because each of the numbers are positive real numbers. Therefore, the sum will also be another positive real number. Okay. For n equal to 2, the maximum product can be expressed as M2 of S equal to S over 2 whole square. Okay, this is given. Subpart C's question is, verify that M2 of S is equal to S over 2 whole square is true or is equal to 12. So, S is equal to 12. Therefore, M2 of 12 is equal to, I'm just substituting 12 in place of X, S rather. So, 12 over 2 whole square, which is equal to 6 square, which is 36. And we have indeed found the maximum product as 36 in the second subpart of the subpart P. Okay. So, we have verified. Same as found in BII. Okay. Hence, verified. Consider n positive real numbers x1, x2, x3 and so on up to xn. The geometric mean is defined as x1 times x2 times x3 dot 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 up to times xn whole raised to the power of 1 over n. That means it is the nth root of the product of these n positive real numbers. Okay. It is given that the geometric mean is always less than or equal to the arithmetic mean. So, the nth root of the product of these n positive real numbers is less than or equal to the summation of these n positive real numbers divided by the number of numbers, that is n. Okay. So, this one is the geometric mean and this one is the arithmetic mean. Subpart D, it is containing two further subparts. Subpart I is saying, show that the geometric mean and the arithmetic mean are equal when x1 equal to x2 equal to, all the values are the same. They are equal. Okay. So, I let x1 equal to x2 equal to dot 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 equal to xn be equal to x. Okay. So, left hand side or geometric mean, I can write geometric mean is equal to, each of these numbers is equal to x. So, this is equal to x times x times x times dot 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 times x raised to the power of 1 over n. And how many x are we having? There are n numbers, so we are having nx. So, x times x is when we have 2x, x times x, it is x square. We have the product as x square. When it is 3x, x times x times x, The product is x cube. We have x raised to the power of 3. So when there are n x getting multiplied, what will be the product? X raised to the power of n. Okay. So this is x raised to the power of n raised to the power of 1 over n. The whole thing is getting raised to the power of 1 over n. And these two will be getting cancelled. So we are having this expression to be equal to x. Okay. And what about the arithmetic mean? Arithmetic mean is equal to, again, all the numbers are the same. So x plus dot 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 plus x over n. When it is x plus x, we are having 2x. The answer is 2x. When we are having 3x, x plus x plus x, the answer is 3x. So when we are having nx, the answer is nx. The numerator will be nx. So this is nx over n. Now this is equal to n. Just writing this as n over here. Okay. Therefore, gm equal to am equal to x. Okay. Shown. So, but I use this result to prove if n of s is equal to s over n raised to the power of n. Okay, it is containing 4 marks. Okay. So, I let us start with this first. Mn is the product, so I'm having this product over here. Let me start with this. And this is, of course, S. This part is S. Okay. So, I can write x1 times x2 times dot 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 times xn raised to the power of 1 over n is less than or equal to s over n. Okay. And this is x1 times x2. Each of the numbers is a positive real number. So the product has to be a positive real number. And s is also a positive real number because it is the summation of n number of positive real numbers, because we are having n over here. So it is the sum total of n positive real numbers. So s has to be positive number, positive real number. N is a positive integer. So we are having positive values on both the sides. So I can just raise both the sides to the power of n. Okay. So I can say, therefore, x1 times x2 times dot 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 times xn to the power of 1 over n raised to the power of n is less than or equal to s over n raised to the power of n. And these two will be getting cancelled. Okay. And so what expression are we getting? What inequality? It is x1 times x2 times dot 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 times x to the power of n is less than or equal to s over n whole raised to the power of n. Okay. Now, what is mn of s? Mn of s is the maximum product of n positive real numbers whose sum total is s. Okay. Now we will be having different products depending on what values are these n numbers having. We will be having different products. Out of the different products that we will be having, sum total will always be equal to s. But we will be having different products. Like if we have two numbers whose sum total is, say 12, the one that we had started with. So I can take the two numbers as 6 plus 6 equal to 12. So the product will be 6 times 6, which is 36. I can take the two numbers as 8 plus 4. This is also equal to 12. But the product will be something else. It will be equal to 32. Okay. I can take 9 plus 3. This is also equal to 12. But the product is 9 times 3 is 27. So the sum total is 12 every time. But the product is different. Okay. So an Mn of S will be the maximum product. Okay. So we are seeing that this portion, the left hand side, is either less than or equal to. So the maximum product will be equal to. For other products, each of them will be less than. Only the maximum product will be equal to the right hand side. And what is the maximum product? The maximum product is Mn of S. So Mn of S should be equal to S over n whole raised to the power of n. Okay. I'm having a sore throat, so sorry. Okay, so therefore, since the maximum product of is x1 times x2 times dot 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 times xn is equal to Mn of S. Obviously, the sum total of these numbers is S. Therefore, Mn of S is equal to S over n raised to the power of n. Okay? Proved. Okay. Now, coming to subpart E. Hence, determine the value of M3 of 12. Okay. So, I can do this part over here. E, I, M3 of 12. So, S is equal to 12. Okay. Mn of S, this is M3 of 12. So, this should be equal to S is 12 and N is 3. So, it is 12 over 3 raised to the power of 3. So, this is equal to 12 over 4. 12 over 3 is 4, 4 cube. 4 times 4 is 16, 16 times 4 is 64. Okay. This one is M4 of 12. This is equal to 12 over 4 raised to the power of 4. 12 over 4 is 3, 3 raised to the power of 4 is 3 squared times 3 squared. 3 raised to the power of 4 is 3 squared times 3 squared, or 9 times 9, which is equal to 81. You can use the calculator as well. And M5, okay, M5 of 12 is equal to 12 over 5 raised to the power of 5. This time I'll be needing the calculator. Okay. So it is 12 over 5 raised to the power of 5. And I have to get a decimal value. So control enter. 79.62624. Up to 3 significant figures, it will be 79.6. Okay. So equal to 79.6 0.6, correct, up to 3 significant figures. Okay. Now, for n belonging to the set of positive integers, let P of S denote the maximum value of Mn of S across all positive values of n. What does it mean? It means that, like, the sum total is S. Okay, so let us take the sum total as 12. We are seeing that we can take the n value as 2. So we are seeing we are having two numbers, x1 and x2, whose sum total is 12. So we can have the numbers as 6 plus 6, we can have 8 plus 4, I have taken 9 plus 3. In fact, I have taken all integers, positive integers, but we can have decimal numbers as well. Okay, so this is for n equal to 2. But they are saying across all positive possible values of n. So n can be equal to 3 also. Sum total remains the same. Sum total is 12. So I can write when n equal to 3. Say it is 1 plus 2 plus 9. This is equal to 12. But this time I have taken 3 numbers. Okay. And what is the product of these 3 numbers? It is 1 times 2 is 2, 2 times 9 is 18. So this is 80. Okay. And so what was the maximum product when n was equal to 2? It was equal to 36. Okay. I can take 4 plus 3. 7 plus 5 is 12. So this is equal to 12. So what will be the product? 4 times 3 times 5. 4 times 3 is 12. 12 times 5 is 60. So you see that sum total is 12. The products are changing according to what values are we taking as the 3 numbers. Similarly, we can take when n equal to 4. What can we do? Maybe it is 2 plus 3, 5 plus 4, 9. 9 plus 3 is 12. So I can write this as 1. And they have not said that you cannot have any repeated number. You can definitely have repeated numbers. 1 plus 4, 8. Okay, another repeated number it is becoming. 4 times 3 is 12. So this is 12. So I'm again having a sum total of 12. This time I'm having the number of numbers is 4. Okay. So that is what is meant by across all positive values of n. Okay. And Mn of S, every time the sum total remains the same, no matter how many numbers you are having. And for each set of maybe we are starting with n equal to 2, then n equal to 3, then n equal to 4. Every time Mn of S is the maximum product for that many numbers. Okay. And P of S is the maximum of all the Mn of S values that we will be getting. Understand? Okay. So, subpart F is saying write down the value of P of 12 and the value of N at which it occurs. Okay. So, P of S is the maximum value. That means we understand that there will be a single maximum value. You will not be having multiple maximum values. Means, so what I mean to say is that there will be a single value of N at which it will be occurring. Okay, maximum value can occur at multiple values of n, but it is not that. It will be occurring at a single value of n. That is what this line is suggesting, that let P of S denote the maximum value of n or Mn of S across all possible values of n. So there will be a single value of n where it will be occurring, the maximum value, that is P of S. Okay, and they are saying find P of 12. So that sum total is 12. Okay. So this one is the subpart F. Okay, so P of 12 Let us start with, since the sum total is 12, let me start with M2 of 12. And we know that what was M2 of 12? It was 36. We have seen that. When the two numbers were equals, is 6 plus 6 plus 12, and 6 times 6 is 36. So M2 of 12 was 36. M3 of 12, this one, is 64. M4 of 12 is 81. M5 of 12 is 79.6. Okay. So we are seeing that the numbers, the values are increasing and it comes to 81 and then it starts to decrease. You can find M6 of 12 also if you want. You can try. You can just get one more. M6 of 12 is equal to 12 over 6 raised to the power of 6, which is equal to 12 over 6 is 2 raised to the power of 6 is 64. Okay, which is less than 79.6. So let me write M6 of 12 as well. So this is 64. So you are seeing the peak value, the maximum value is 81. Therefore, P of 12 will be equal to 81. Okay, therefore, P of 12 is equal to 81. Okay, now coming to support G. Determine the value of P of 20 and the value of N at which it occurs. Oh, sorry. Write down the value of P of 12. I have written the value of 12 and the P of 12, but and the value of N at which it occurs. It is occurring at N equal to 4. Okay. So at N equal to 4. Fine. So coming to P of 20. This should be equal to maximum of, what was the Mn of S expression? It was S of N, S over N, whole raised to the power of N. So this is S is 20, okay, because it is P of S and P of 20. So S is 20. So maximum of Mn of 20, which is equal to 20 over N raised to the power of N. Okay. And for this, we really need the calculator. We have to graph it. Okay. So let me go to the graphs. It is, I'll be taking X in place of N. So it is 20, divided by X raised to the power of X. Okay. Fine, enter. 20 over X raised to the power of X. Okay, and I am not seeing any. Let me just take menu. I go to menu and let me go to Windows settings. Let me change the Y values. The X will be all positive real numbers. So let us say I'm not disturbing the X values right now. I am more concerned with the Y values. So we'll let this be and this be. What should I be taking? Let me take 1000 first of all. Doesn't fit. So I have to take more than 1000, 2000. Enter. Yeah, now it works. Now it works. Okay, fine. So I have to get the maximum. Analyze graph and maximum. Okay, so x is the n. The maximum value is 15.1568.05 at when x or n equal to 7.35759. But n is a positive integer. I cannot take n value as 7.35759. So I have to get a value. Either I have to take 7 or I have to take 8 or I have to take 6. Okay. I have to take one of these three values. So let me start with 6. Let me use the graph trace. You can use the graph trace or you can use the calculator. Okay, let me show the calculator way first of all, and then I can go to the graph trace. So this one is 20 divided by 6 and raised to the power of 6 is this. And 20 again, 20 divided by 7 raised to the power of 7. It is this one. And next one is 20, where is it 20? 20 divided by 8 raised to the power of 8. This one is 1525. I'm just reading the digits before the decimal point. This one is 1371. This is 1554. This is 1525. Of course, you are having the digits after the decimal point, but because we have to give the uh, answer up to 3 significant figures, so it will be, I'm seeing when n equal to 7, we are getting the maximum value, and the maximum value will be 1550. Okay. This is the way that you can find using the calculator, or else you can come to this graph and you can use the graph trace, and you can see what is the value when x equal to 6. You see x equal to 6, 1371.74. When x equal to 7, what is the value? It is 1554. And when x equal to 8, this is 1554, remember. When x equal to 8, it is 1525. Okay. So obviously 1554 is more than 1525. So n value should be equal to 7. Okay. I've shown you both the methods. Okay. So the answer will be 1550 up to 3 significant figures. Okay. So using GDC graphs, P of 20 is equal to 1550, correct up to 3 significant figures, and n is equal to 7. Okay. Okay, it contains just 3 marks, so it is fine. Consider the function g defined by ln of g of x equal to x times ln of s over x, where x belongs to the set of positive real numbers. A sketch of the graph y equal to g of x, this one, this is y equal to g of x, is shown in the following diagram. The point E is the maximum point on the graph. This is the maximum point. Okay. So subpart H is having this question. Find in terms of S the x coordinate of the point E. Okay. So E is the maximum point. Therefore, and we are given this expression. We do not know what is the expression for g of x in any other place. We are not given that. This is the only expression that we are having. So since this is the maximum point, we know the g dash x, the first derivative of g of x, will be equal to 0 at this point, right? So let us differentiate this equation. Okay. So h ln of g of x d dx, I'm differentiating both the sides of the equation, equal to d dx of x times ln of s over x. Okay. So this one is, this is a composite function. So first of all, it will be 1 over g of x. And then you have to differentiate this g of x. So it will be g dash x, the first derivative of g of x, equal to this side we have to use the product rule. Okay. So first of all, I am differentiating the x with respect to x, which is 1. So I am getting ln of s over x plus x times ln of s over x. So it will be 1 over s over x times the derivative of s over x. S is a number, a positive real number. So I can write this, I'm just doing this over here. Okay, I can write s over x as s times x to the power of negative 1. Okay, s is the coefficient, so it is s, and the negative 1 comes down, so it is minus 1 times x to the power of minus 2. This will be the derivative of this s over x part. So I can write this as minus s over x square. Okay. So this will be equal to, and I have written this part. I don't know whether I'll be needing it, but I have just written the expression of this. Mx of x is, sorry. So this is equal to ln of s over x plus x, or let me write minus. Okay. I'm writing the minus because there is this minus sign. So x times 1 over x, s over x is x over s times s over x square. So these two will be getting cancelled and these two cancels, and we get the expression as g dash of x over g of x equal to ln of s over x minus 1. Okay. So therefore, g dash of x is equal to g of x times ln of s over x minus 1. And because we are concerned with this point E, which is the maximum point of the graph, where the g dash x value will be equal to 0, so this should be equal to 0. Okay. And obviously the function expression will not be equal to 0, means we are not seeing g of x equal to 0 anywhere in the graph. Never are we seeing the g of x value equal to 0. It is not touching the x-axis anytime. Okay. So g of x is definitely not equal to 0. Since g of x is not equal to 0. Therefore, ln of s over x minus 1 is equal to 0, or ln of s over x is equal to 1. This implies ln of x is equal to e raised to the power of 1, or we have to give the x coordinate. So, x is equal to s over e. Okay, for the point A. You can give the 1 over e, you can express it in decimal. I'm keeping it as s over e. Okay, so we come to the subpart I. Verify that g of x equal to mx of s, where x belongs to the set of positive integers this time. Okay, because it has to be, because we had mn of x where n was a positive integer. Okay. So again we will be taking the same, we'll be starting with the same expression by equation, because we don't have any other expression for g of x. So it is ln of g of x is equal to x ln of s over x, which can be written as ln of s over x raised to the power of x. And we can cancel the two ln's. So this implies g of x is equal to s over x raised to the power of x. And now we can use this expression, which we had found, which was given to us, in fact. So in place of x, we had just n. Over there, n was a positive integer. Here, x is a positive integer. So this is equal to mx of s. Okay. So verified. Coming to the last part of this question. Use your answer to subpart H. Okay. This one. To find the largest possible product of positive numbers whose sum is 100. Okay, largest possible product. Okay, and you see g of x is equal to mx of s. So g of x is giving us the maximum products for each x value. Okay? And we have to get the largest possible product. So therefore, it will be the maximum value of g of x. Okay. So to find the largest possible product of positive numbers whose sum is 100. Okay. Give your answer in the form of a times 10 to the power of k, where a is greater than or equal to 1 but is less than 10, and k belongs to the set of positive integers. Okay. So, first of all, g of x equal to mx of s. Okay, and we know that the maximum possible product will be corresponding to this point A. So, what is the x coordinate of this point A? It is s over e. And what is s? S is given to be equal to 100. So, x coordinate will be 100 over e. So, now we have to find the y coordinate, that is mx of 100. Okay. So, this is j. Since g of x is equal to mx of s, Therefore, the maximum product will correspond, it is containing just 3 marks, okay, will correspond to the maximum point, or maximum value of g of x, which is the y value of point A. Okay. So, therefore, point A, what will be the coordinates of the point A? X coordinate is S over E and S is 100 given. So, the X coordinate is 100 over E. And what is the Y coordinate? Y coordinate is mx of S, and what is that? S over X whole raised to the power of X. So, in place of S, I can write 100 divided by X is 100 over E. So, 100 over E whole raised to the power of 100 over E. Okay. So, this is the Y value and this is the maximum possible product. Okay. So, therefore, I can write this as E goes up 100 E over 100 raised to the power of 100 over E. Okay, and these two will be getting cancelled. So, it is basically E raised to the power of 100 divided by E. Okay, and I have to get this value. Okay, let me first of all get this value. E raised to the power of E raised to the power of 100 divided by, I am writing E raised to the power of 1. I have no other option. So it is this way. Let me see what answer do I get. 9.4798 and all, and E 15. So it is times by 10 to the power of 15. So it will be 9.48. Okay. So I'm taking 9.48 times 10 to the power of 15. Okay. Using GDC. So therefore, largest possible product is equal to 9.48 times 10 to the power of 15. Okay. Fine. So we have completed solving this question number 2. Thank you for staying with me till the end. I'm Nilanjana Sanyal. I'm an online IB Math SL and HL level tutor. I tutor students from both within India and outside India, and I offer both one-on-one and small group online tutoring services to my students. And in case you are liking my explanation, please to give this video a like and please to share this video with your friends so that even they can get benefited by watching my video. And please subscribe to my YouTube channel. In case you have not subscribed to my channel till now, it will be motivating me to make more math videos for you. I'll be knowing that I'm being able to help you. And we meet again very soon in our next session. We'll be starting with the next new paper. So till then, bye.